us over 20 years to build what you see around you. So don't be intimidated. But here it's a little too loud. Let's go somewhere quiet. Welcome back. Now that it's quieter, let's begin our presentation. This is a very brief introduction into chemical engineering at Caltech. I am Professor Konstantinos Giapis, and I began this presentation by showing you my most complex experiment in my lab. Next slide, please. So, we use this apparatus to study exotic reactions in astrophysical environments, such as comets and moons of Saturn. But wait a minute, this is a presentation in chemical engineering. Why did I begin with astrophysics? Alright, so, well, then I need to tell you what a chemical engineer is. Next. So, I decided to give you a quiz, because I believe you are somewhat informed about what a chemical engineer is and does. So, who is a chemical engineer? A, an engineer who manufactures chemicals. B, a chemist who works in a factory. C, a glorified plumber. And D, an engineer who can do magic on a grand scale. Well, which one is true? The first one is a description of chemical engineering. Very descriptive, but is it really true? The second, well, any chemist can work in a factory, so that cannot be truly an engineer. C, a glorified plumber. Well, this is something that we do a lot in chemical engineering. Not actual plumbing, but designing pipes, designing flow-through pipes, and some other things that relate to piping. That's not what chemical engineering is. But D is something that I threw up there because actually it's closer to the truth than any of the other three. But let's see what Wikipedia says about chemical engineering. Wikipedia defines chemical engineering as a branch of engineering that uses the principles of chemistry, physics, mathematics, biology, and economics to efficiently use, produce, design, transport, and transform energy and materials. That's actually quite accurate, but not all-inclusive. The work of a chemical engineer can range from the utilization of nanotechnology and nanomaterials in the laboratory to large-scale industrial processes that convert chemicals, raw materials, living cells, microorganisms, and energy into useful forms and products. This is true, but also not all-inclusive. Chemical engineering is all of these things and more, a lot more. It's the most versatile form of engineering. Why? Because most engineering disciplines use physics, mathematics, and maybe economics to deal with problems. Chemical engineering is the only one that invokes chemistry, uses chemistry extensively, and increasingly biology to work with materials, to work with products, to work with processes. Next. It's the most versatile form of engineering. And I will use an example of what chemical engineers do from 110 years ago. Next slide, please. And this is to tell you about the Haber-Bosch process. The Haber-Bosch process addresses the production of ammonia and nitrogen fertilizers. 110 years ago, the world was running out of natural fertilizers. So, we couldn't grow enough food to feed the population of Earth. The population was expanding and there was not enough natural fertilizer. So there was a need for artificial, for chemically synthesized fertilizers, nitrogen fertilizers. And Haber-Bosch process solved that problem. Next. Here are the two gentlemen that gave their name to this process. Both were Germans. Fritz Haber was a physical chemist who invented the process that I will tell you about. And Carl Bosch is the one who took it to practice, who made nitrogen fertilizers on a grand scale and had the most impact in the agriculture of the 20th century. So what is the Haber-Bosch process? It's the conversion of nitrogen into ammonia by combining it with hydrogen and making ammonia. How do we do that? Well, we need a reactor where we will actually force these two gases to react together. We put a catalyst inside that reactor, we bring the two chemicals in, we adjust the pressure and temperature, and magic happens. We make ammonia. Ammonia is also a gas under the conditions of this reactor. We need to extract it, so we need to liquefy it. So we take everything into a condenser, we remove the ammonia out of the mixture, and we recycle the nitrogen and hydrogen that has not reacted back into our reactor to produce more ammonia. Okay, this looks very simple. It was invented in the laboratory of Professor Haber, and he got the Nobel Prize for it. But taking it into practice, he couldn't do. He needed an engineer to do that. And that's where Carl Bosch comes into the picture. Now, 110 years ago, chemical engineering was not really a discipline. In fact, Carl Bosch studied metallurgy and mechanical engineering, but he wasn't happy with just these two disciplines. He wanted to know chemistry, so he actually went and got another degree in chemistry and became one of the first chemical engineers. So what did he do? He took the idea and then he transformed it into a grand scale. He made it work in a big factory environment. We needed fertilizers by the truckload. We needed it at extremely high quantity because, again, the population of Earth was growing. So he figured out how to do this on a grand scale. He figured out how to use less expensive catalysts to make fertilizers cheaper. He figured out how to make it more efficient. This and a lot of other things is what chemical engineers do. Now take the word fertilizer out of this picture and try to think in terms of other materials, such as, for example, pharmaceuticals. We all need medicine. How do we make medicine in quantity? Take, for example, polymers. Polymers are pervasive in our society. We need to make them in large quantity. That's another thing that chemical engineers do. But this proliferates to basically everything that is manufactured. Chemical engineers get involved with every aspect of materials processing. So chemical engineering has pervaded every discipline, every scientific discipline, including astrophysics. That's a newcomer, comes from my lab. Okay, so now that I told you all this, I will tell you a few more things about what is happening at Caltech. As I said, you need to know, in addition to mathematics and physics, also chemistry and biology and economics to deal with what chemical engineers do. That's a very broad background, and it has a lot of requirements, and that reflects in our curriculum. It has a lot of requirements, for undergraduates. At the same time, we realize that chemical engineering has become so broad that it's impossible in 4 years to actually cover everything that chemical engineers do. So we decided to split our program into 5 different directions, or 5 tracks as we call them. Next. So chemical engineering at Caltech then consists of 5 tracks, 5 different directions that you can take as a chemical engineer. Process systems, materials, biomolecular, environmental, and computational track. Process systems is the classic chemical engineering track, where you actually do what Carl Bosch did. You take a process that the chemist has invented and you transform it into practice. You make everything in grand scale. But then there is also the materials track, and in fact the materials track needs to be split into soft materials, polymers, and hard materials such as electronic materials, semiconductors, because chemical engineers do work in making better microprocessors and denser computer memories. There is also the biomolecular track, where you use your knowledge of biology and biochemistry in chemical engineering type of applications. There is the environmental track that is unique to Caltech. We have 2 professors here who do work in the environment and try to figure out eventually problems of how to solve problems of that relate to the atmosphere, that relate to removing pollutants from the atmosphere, that relate to how the atmosphere works. And the final track is the computational track, because computations are used extensively in chemical engineering. And in fact, there is so much demand lately that we decided to introduce this additional track and specialty in chemical engineering. That was all I had to say today. There will be a questions and answers session coming up where I will try to interact with you live. Goodbye.